In this lesson, we are going to see how aluminium is extracted using electrolysis. Electrolysis, it's a process in which electrical energy is supplied to break the chemical. Now, the aluminium is a metal that is very useful. It's less dense than iron and it does not rust. You know the aluminium foil, and it is used in making aeroplanes, bicycles and cooking parts, even overhead cables, because you can't use iron which is very heavy, so it is used for many. All the cool drink cans are made out of aluminium. So now we do not have aluminium in South Africa. What we get is we import the aluminium ore from Australia, and BHP Billiton, they have got in Richards where there's a plant that is extracting aluminium. And these processes are expensive in the sense because you have to supply lots of electricity. So the bauxite contains the very important chemical aluminium oxide. You want aluminium, but aluminium is not available as it is. But if you take gold and platinum, they are available as it is. But these metals are combined with oxygen. So now how to remove the oxygen? That is what you mean by smelting or extraction of aluminium. So aluminium oxide is there. So first when they bring it, it is not very pure. So it has to be cleaned. So they use the sodium hydroxide, which is we have seen that in acid-base topic, it's a strong base. They use sodium hydroxide solution to purify that, so that all the impurities are removed as red mud. The red mud is a combination of silica, which is sand, iron, and all those impurities are there. So when you clean using sodium hydroxide, the red mud that is coming as a waste will have lots of sodium hydroxide. If you dump it in a particular site during the rain, all the sodium hydroxide will drain into groundwater. It will make the water, underground water, alkali. If you use a borehole, if you take the water will not be neutral. So that is the environmental impact of this purification. Now in this plant, they take the aluminium oxide and they mix it with cryolite. Aluminium oxide is an ionic solid. You have learnt in the previous classes, ionic solids do not conduct when they are in the solid form, because the ions are held tight in the crystal lattice and they cannot move. So how to make them move? Either you melt and dissolve them in water, but here we do not want to have water, we want to melt them. So when you look at the melting point of this, it's 2000 degrees Celsius, which is very high. So the process is going to be very expensive. If you add any other solid into that ore, aluminium oxide, it decreases the melting point. What is the chemical that is added is cryolite. The formula for cryolite is Na3Al(F6). This chemical is added to aluminium oxide. It decreases the working temperature of this plant from 2000 degrees to 900 degrees Celsius. So it saves lots of energy, and also economically it is viable to carry out this process. So now this here, the container itself acts as a cathode, and it has got, a cathode is negative, and you have got carbon which acts as an anode here. Here the carbon rods are joined together and it is just dipped into this solution, and if they want they can take it out. The reason I will tell later. So now when you pass electricity into this one, it is going to be split into aluminium ion and oxide ions. What are the two ions present here? Aluminium ion is Al3 plus, oxide ion is O2 minus. During electrolysis, positive ions goes to negative electrode, negative ions goes to positive electrode. Let's talk about the negative ion. Negative ions, I said non-metals always goes to anode because they are negative and they go to anode. So what is the ion that is present? O2 minus. And the O2 minus, what does it do? It undergoes oxidation and becomes oxygen. Oxygen has got how many? It is going to give electrons. It's going to give oxygen plus 2 electrons. But oxygen is not monoatomic, it's diatomic. So it is O2, and instead of 2 electron, what is it going to become? 4 electron, and here also it's become 2O2 minus. 2 oxide ion joined together to give 1 oxygen molecule and 4 electrons. So this is an oxidation reaction. So you can see that oxygen molecules are coming to the anode. Oxygen molecules are that supports burning. So what they do during this process, there is another reaction going to take place at anode. The oxygen that is produced reacts with the carbon anode and converts that into carbon dioxide. So the electrode is burnt here. That is why they have this process, so that they can dip it. When it is finished, they can replace it. The carbon electrode is replaced every now and then because it is already used up during this burning process. Now cathode, what happens in cathode? Al3 plus, it undergoes reduction and forms aluminium. When the aluminium comes out of this plant, it's a liquid. It is a hot liquid. So if you want to make a cool drink can, you pour the hot liquid into that mold so that it can come to a particular shape. If you want aluminium foil, you run through a thin layer and you can get aluminium foil. So this is how the aluminium is prepared and used for many other purposes. But apart from this red mud pollution, causes sodium hydroxide into groundwater, the carbon dioxide is also going to cause global warming and acid rain. And from this cryolite, there is F minus emission, fluoride ion emission. That is also not good for human health. And during this process, they use lots of electricity. We produce electricity by burning coal, so that also causes pollution. So every industry has got some economical impact. Apart from that, it provides jobs and foreign currency. Those are the advantage of these industries. Thank you.